Hi everyone. Thank you for all attending that talk about how open source powers the modern data stack. First, a little bit about myself. I'm Michel Tricot. I'm the co-founder and I'm the CEO of Airbyte. I've been working in the data space for the past 15 years, and I've been at companies in like very big data, moving petabytes of data every single day. And one thing I've learned from there is that moving data from point A to point B is extremely messy, and that's what actually motivated me and my co-founder and the team to really build Airbyte and to take an open source approach so that we can really rally a community of users and a community of contributors around solving the problem of data integration. Today, Airbyte has about 35,000 deployments. We released the first version back in October 2020. So 2021 has been like phenomenal adoption of Airbyte. And if we also have a pretty large community of Slack users, of people asking for advice, people general advice about the data stack or advice about Airbyte. And we have about 400 contributors on the project, so helping either on the platform or on building data connectors and helping the community to maintain these data connectors. So, perfect. So the first thing is, before we get started on what the modern data stack is, I just want to level up the plane on how have we approached data management, data pipelines, data processing over the past, since data exists, basically, and how it has changed over the past 6 and 7 years. So when you think about the old model, which is what we call ETL, which is extract, transform, and load, it's really about how do you pull data from an external source. It can be an API, it can be a database, it can be a file. And then you feed that data into your transformation engine, meaning that you have a very tight coupling between your extract and your transformation. And the transformation is actually when you're going to modify and introduce your business bias or your analysis bias into the data. And then once you've done your transformation, once you've done like your analysis, you're going to load the result of this analysis in a place where people in your company, people in your team can start consuming the results. And the problem with this, with ETL is, first of all, technology has evolved a lot. So that's a model that worked really well when compute was expensive, when storage was expensive, but it doesn't work in today's world. The first problem is it's very inflexible. Because you have this tight coupling between extract and transform, it means that it is very hard to add new data, to add new analysis on top of that data, because the data you have has already been transformed by a previous analysis. The second problem is it belongs in the realm of only data engineers or technical people. And that's a big bottleneck in organization, because now every time your business team, every time your product team, every time your engineering team or any function in your company needs to run a new analysis, they need to involve engineering. They need to involve data teams. So you end up with companies with massive data teams just focusing on like creating all these pipelines, creating all this analysis and transformation based on the inputs they get. And the third one is these are complex systems because you have this tight coupling between extract, transform, and load. In general, you have like big end-to-end solution, and they address 70% of your needs. The moment you start to go a little bit on the side of how the system was planned to work, you are going to have to build something internally, or you will have to rebuild something in parallel. And this is something that's going to be homebrew in your company and something that your team will have to maintain. The way the world has changed is, especially with modern lakehouses, modern data warehouses, is that compute is cheap, storage is cheap, so you can afford to store way more data directly into your compute engine. And you want to also push all the introduction of any kind of business bias, any kind of like business information in the data as far as possible in all your data value chain. You want to make sure that everyone in your company will have access to very raw data and most of the data that is available. So first thing is, because you have all the data at the destination level where you process the data, you get a lot of flexibility. Data consumers, whether they are engineers, whether they are analysts, whether they are analytics engineers, they can just go and they have access to everything, unbiased data. The other piece is autonomy. Because these extract and load primitive are very general purpose, you can create application that just allows them to self-serve on bringing the data into the warehouse. So you make them autonomous. It means that now your data team is not the provider of the analysis, is not the provider of data pipelines, they are the provider of the platform that enables these teams. And the last one is, it is future-proof. The raw data is very rarely affected by business or transformation bugs. Yes, sometimes the source has a bug, but that's very different than having your whole analysis and your whole transformation to have a bug that forces you to re-import the whole data. So it makes your team more reliable, and it makes your data pipelines more reliable. So now on the modern data stack. What we've seen is more companies rely on data today. And the company who don't are going to lose something. They are going to lose competitive advantage. They are going to lose insights that could bring their business to the next step. But the thing is, all these companies have different needs, and they also have different capacities. So some companies might need to process image data, structured data, unstructured data. Some others might have a large team of data engineers. Some don't. So if you take, for example, a fraud company, they will also have very strong requirement around turnaround. They need to have data within the minute or within the second. Whereas, a B2B healthcare company just need to have the data every hour or every day. So all of that makes that it is very hard to have one end-to-end system that just addresses all the nuance that your business needs for data. And that's where the modern data stack comes into play, which is how do you actually compose your data stack with building blocks? How do you compose your whole data value chain by assembling the best tools for the need you have today and potentially for the need you will have tomorrow? So typically here, if you think about Databricks as your processing engine, then first question you will ask yourself is, today I need to bring data from Stripe. I need to bring data from my Oracle database. Let's use Airbyte. I actually need to bring data from this very obscure enterprise software, or maybe I'm going to pay this other service to do it. But you just start assembling building blocks that feeds into your processing engine. And then on top of that, you can add all your business requirements, like what kind of quality do you want to apply on that data? How do you want to actually process, transform, and enable your team to do analysis? So you can be using dbt, you can be using just raw SQL, or you can just give them access to Looker to do it, or Superset to just dig into what the data looks like. Same thing for observability. You have the choice with tool, and you're not forced into a one end-to-end solution. You can just pick the best for you today and the best for you for the next few years. And of course, all of that needs to be running on most infrastructure because not everybody is on cloud. Some people are using multi-cloud. Some people have a mix of on-prem and cloud. So these type of data systems, they need to be able to work across multiple platform, multiple infrastructure system. And that's how you actually, that gives you the ability to select which blocks works the best for this particular system. And so what do you get from it? So on one side, you get, on the technology side, you get a system that is future-proof. It means that because it's an assembly of building blocks, you can decide, today I need X and Y. Tomorrow, I need a new version of X. I need something that is better for quality. So you will just replace that existing building block and replace it by the one that solves your new problem. You get more innovation because since you can swap these building blocks you can use better technologies. If you're stuck with SQL, maybe you want to go and use something like dbt. But if you have like one single product to do it, you will always be stuck with the tool that has been built into your system. And gives you the flexibility, it gives you the extensibility. Today, you might not care about data quality. Tomorrow, you have a data outage. Suddenly, data quality becomes important. And on the organization side, having the modern data stack gives you this concept of the team builds a platform for the rest of the company. Meaning that part of this building block is you can bring application that target specific persona within your company. It can be data analytics, analyst, it can be analytics engineer, it can be a finance person. It gives you the choice of what is the interface that they can use to actually work with that data. And you don't have to build them. You just take them, and now you can really focus on your business. Like, you have your data platform, people can self-serve, they can bring you the insight, and that's really what you get. And you can evolve it. So what does it look like in practice? So here, what I've done is I've really focused on what I call like a bit of the backbone of building the data stack. So what are the key components that you need, and then how you can plug in additional features on top of your data stack. So first one, obviously, Airbyte. The first need that you have when you're building your data pipelines is, how do I get data in? And Airbyte is here to help. So it's open source. You take it, you download it. It's on GitHub. It has about 180 high-quality data connector. If by any chance there is one that's missing, or if you need to upgrade one that already exists, you have access to a lot of tooling to actually build these and maintain them extremely fast. We call that the CDK, like Connector Development Kit. And if you need help, you have a Slack community, we have a Discourse channel, and we also have amazing data architect that can help you on how to better design your system. The way it works, more like going into some of the high-level technical details, is it's all based on top of a data exchange protocol. So, which is the lowest definition of what does it mean to move data from point A to point B. How do you do schema management? How do you expose your data? How do you transfer binary data, et cetera, et cetera. And once you have this protocol, on top of it, you can build every kind of connectors that you want, whether they are source, whether they are destination. Source is obviously pulling data from a system. Destination is just loading the data into a system. And this is really what we call the connector layer. And on top of that, you have the platform, which is all the intelligence about operating this data connector. And it can be about how do you manage incremental updates. I mean, if your database is, something in your table is changing, you probably don't want to import the whole table every time you have a record that changes. So how do you keep track of where you need to, like data that has changed? And it can be an API, it can be a database, it can be a spreadsheet, a file. And it's like the platform is also meant for different profile of people that are consuming data. We have a UI for potentially less technical people, or people who don't want to have to deal with an API, who don't want to have to work with a CLI. And we have CLI for people who want to version control, like Airbyte configuration. We have an API for if you want to programmatically build tools on top of Airbyte. So that's really how it is built. Now, second step is how do you do your transformation? In the open source world, I mean, today there is a pretty clear winner, a winning product, which is dbt. It's open source, and it really allows you to bring the best practices of software engineering into the data world. So how do you do version control of your models? How do you do testing? How do you package your analysis and make them portable into other systems? And it really allows you to just have less technical but extremely data efficient people to work and be efficient with data. And last is superset, which is how do you enable people that are even less technical, but that understand extremely well how to do data exploration, how to expose data to the rest of their team. And same thing, open source works on most warehouses, most lakehouse. And this is what it looks like. Very simple. Left, get your data into Databricks. Right, activate your data. like how do you expose it, how do you consume it. And all of that with dbt in the middle that helps you take that raw data and make it data that is actionable. And there is also a new use case that's becoming more and more popular that we call reverse ETL, which is once you've done your analysis, when you've joined data sets together, you might create new type of derived information. And this derived information, you want to make it available not just in your analytics platform. You want to make it available into your operational platform, whether it's your Zendesk, your customer interaction system, whether it's Salesforce, HubSpot. And this is the next step of the data movement, which allows you to bring that data from warehouses and leverage it and make your sales team, your marketing team able to leverage it. And I mean, yeah, as I mentioned, we have about 35,000 deployment of Airbyte, and this was this testimonial really embodied what the modern data stack is, which is this is a startup, pretty big actually. They do e-commerce. They do a lot of end-to-end analytics on e-commerce, including like omni-channel attribution, et cetera, and they don't want to be building a data stack. They don't want to be building infrastructure. What they want is they want to do ML on top of the data that they have. They want to present this data to their customers. And what they've done, it was about a year ago, they took Airbyte open source, started to play with it, and now it's really part of their product. It became the building block for how they bring their customers' data in their analytics system. And boom, there we go. Let's see a small demo. So I'm going to do something very simple today. And you know, I'm going to demonstrate Airbyte today on the cloud version of Airbyte, but you get exactly the same thing on open source. You just go on GitHub, pull the project, and you can start running Airbyte the same way I'm going to show right now. So the first thing I'm going to do is, let's create a source. Let's say I'm an open source project. I have a lot of GitHub information. So let's search for GitHub. Up. And now let's feed in all the information that I might need. So a few, like obviously you need credentials to connect to a system, and then you can start setting up the source. And this is really what I mean by making your data system a platform for the rest of the company. Not everybody knows how to write a YAML file. Not everybody knows how to configure a data system. And here we're just expanding the API, expanding the CLI interface into a UI so that anyone can start creating new data sources and new data pipelines. And then let's go on the destination side. So Databricks. Perfect. So here I'm getting all the configuration in place. And let's go on US East 1. And let's keep temporary data, like staging data. So yeah, what's happening behind the scene is it's testing the whole configuration against the production system, just to make sure that you've entered all the options the right way. Very good. I forgot this one. So we need to agree to terms and conditions for using. Up. That should work. And one thing that we've done also is part of the development of connectors is to have very specific guidelines on what a good connector should be, so we can guide our contributors to build high-quality connectors. It's not always going to be the highest quality, but with time, with more usage, it's going to become better and better and better. And part of it is obviously documentation, like what are all of these fields about, and making sure that it's available for people that are configuring sources and destination. Okay, so now I have a source on GitHub, I have a destination on Databricks, and let's connect the two. And so the Airbyte is very schema-driven. So what we do whenever we configure sources, we are going to discover schemas. And what we're also working on, both on open sources and on cloud, is how to better handle like schema migration. We already have some early version of it, but we want to give more control to our users to decide for this specific type of data, this is how I want to handle schema changes, and potentially connect to other systems that are managing schemas. So let's go on the vanity side. So I'm going to get for how many people have starred on GitHub. So Stargazer, boom. And here you have, like every source exposes all the data streams that are available. So if you're pulling from a database, that will be the list of all the tables or views available. If it's an API, it's going to be potentially an endpoint. And let's test it. There we go. So first thing that it does is it just starts reading data from GitHub. Is going to stage that data directly into the Lakehouse, and then is going to issue command to the Lakehouse to actually load the data directly. So while it's syncing, let's wait a little bit. It's just about like 8,000 stars, so that should go fast. And obviously, in terms of destinations, you can have a lot of same thing. Because it's built on top of the protocol, you can decide to make your destination a warehouse, a lakehouse, like a blob storage, but you can also make it an API. If you are able to connect, or you can make it like Elasticsearch for what it's worth. Like everything where that can store data, you can send data to. There we go. And it runs on top of Kubernetes right now, meaning that you can get almost, I mean, as long as you can pay for it, you can get as much scale as you want. So if you have 1,000 type of data replication, data sync, even more, it just goes and runs on your Kubernetes cluster, and we use all the resources available there. Cool. I think we're good. Let's go in Databricks for now. Oh, you know what? Let's go in here. Databricks test bucket. Oh, no, not this one. Yeah, I think the data is still loading. 1 second. Oh, yeah, it's coming. And right now what we've done is try to expose as much information to our users, and so that you can get a sense of what is actually happening, where you might have some performances issue, indexes that are missing on databases. And there we go. So succeeded. Did not sync that much data, but API data is generally extremely valuable when you replicate it. So let's go there. Okay, let's go in Databricks directly. Up. Yep. So this is why I have my data in Databricks, Stargazer. That's the stream of data that I've started to replicate. And when you start exploring the data, so we leverage, all the schema is obviously converted to Avro schema. And you can see that you can handle both like very tabular data, but also nested data directly. And there you go. You have access to all the data. And it took me, okay, if we exclude the time that we had to wait, like 2 minutes to configure. And this is how you enable your team to bring data fast and to be efficient and extract what they need from data. Cool. And that's all for me today. Thank you very much for being there and for listening to me and watching this demo.
Any questions? Raise your hand for questions.
Thanks for the talk. One question: if you assemble Lego blocks, perhaps you don't need an engineering team on the ETL part, but you need engineering team to create the Lego blocks, combine the Lego blocks. How do you look at that?
That's correct, and that's also one of the reasons why, like all the orchestrator like Airflow, like Prefect, Daxter are so popular, is that they become a bit of they encode how all these building blocks should interact with each other. Like typically Airbyte can integrate directly into Airflow, DBT integrates directly into Airflow, and you can start having more this high level, like what should my data stack and my data pipelines look like? And same thing for Prefect and for Daxter. So yes, there will always be some work on the data engineering side, but it won't be about how do I actually build a connector to bring this data. It won't be about how do I build a completely new quality tool to make sure that my columns are not changing or that the variance of my numbers are not changing. So there will always be this orchestration layer on top of it, but it becomes simpler and simpler. And the simpler it is, the less issue you have with it, the less maintenance you have. And if you look at this diagram, actually this orange line at the top is trying to really say that it is still orchestrated by something. It commands Airbyte, it commands DBT, it commands high touch, etc., etc. And that's going to be still going to be the responsibility of data engineers. And there will be a moment when this scheduling can also be configured directly by potentially non-data engineers.
Hi. Congrats. Just to know about the roadmap, about the stream analytics or streaming source or destination.
Yeah, that's a good question. So I would say that streaming is an important use case for us. What we had decided when we studied Airbyte early on was let's focus on what we call micro batches, which is minute granularity data replication. There is on our roadmap, and this is something we're not going to be working on in 2022, but in 2023, which is how can we start actually ingesting real-time ephemeral data directly into Airbyte. So this is something on the roadmap. One thing that we want to solve is data movement. If we don't address streaming, we don't address data movement fully. But for now, we really focus on micro batches, and in general, that covers 99% of all the use cases in the world today. Does that answer your question?
Other questions?
Just a follow-up, how frequently you can have, if it's a micro batch, you can go 5 minutes, 2 minutes, 1 minute? What is the max frequency?
The max?
Yeah.
Oh, I mean, the minimum is just for, I would say, because there is resource allocation happening behind the scene. We try to limit to 1 minute so you don't do it every second. But one would say that good practices would not be to run it more than once per minute.
I actually have a question. How does Airbyte work for reverse ETL?
So, very good question. Today we have only one. We have an experimental use case, sending data into a search engine that is backed by an API. But we are really focusing on what we call the bottom of the pyramid, which is first, let's get the data into your warehouse. Because if you just go directly to reverse ETL and you don't have data in your warehouse, you're not going to solve a real problem. The first question you will get asked is, how do I get data into my warehouse? So right now we're really focusing on the first leg. 2023 is going to be about the second leg. But the protocol has been thought so that we can address that use case. And there will probably be some layer of abstraction and like modeling that we need to bring on top of it, but that's coming.
Awesome. Well, thank you so much for your time. Remember to rate this session, and appreciate your time.
Thank you very much.